Carbon dioxide, carbon monoxide, and diarsenic pentoxide are all examples of binary covalent compounds. They're binary compounds because they're made up of only two elements, and they're covalent because they have two nonmetals bonded to one another. The names also give us clues as to how many of each type of atom are present in their chemical formula. Carbon dioxide may more commonly be known as CO2. Carbon monoxide is CO, and diarsenic pentoxide is going to be As2O5. The prefixes written before names, such as di, mono, di, and pent, all tell us the number of atoms that are associated with that particular element. Notice, too, that the endings for each of the second element has been changed to ide, IDE, and dropped the original ending to each element's name. The prefixes that are associated with each number are Greek. You may have seen them before when you've worked with polygons. Mono represents 1, di represents 2, tri represents 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. Oftentimes we end up dropping the last A of the word if there's two vowels in a row. So let's try turning a name into a formula. First, we need to know what the chemical name is. If we're given the name chlorine dioxide, we know that there's only one chlorine atom. The di in front of the oxide means that there's two oxygen atoms. So when I go to write this as a chemical formula, I'll end up writing it ClO2. Try predicting this next one on your own. The name is tetraphosphorus pentasulfide. If you wrote the following formula, P4S5, you would be correct. Hopefully you recognize this flowchart as the one from your packet. If you look at it, you'll notice that it has all of the steps you want to take in order to turn a chemical name into a chemical formula. So let's go through this flowchart, and we'll use the example carbon tetrachloride. We're going to treat each word as a separate element. So the first word we're looking at is going to be carbon. There is no prefix in front of carbon, so that means there's just one atom of carbon. In front of the chloride, we've got a tetra, which means that there should be 4 chlorines, so we'll write that as Cl with a 4 subscript. Now when we write chemical formulas, we never include a 1 subscript, so the final answer for this is going to be CCl4.